right, let's go over this warm up. I have this first page in a separate video because it's primarily first semester review material, and I opted to not have us do this particular year, but maybe in the future I went ahead and made a separate video in case it was needed. All right, so we definitely want to make sure that we know how to compare two totally different things, and we would do that by getting a standardized date statistic. So we found out what our z-score then was for the Dalmatians, and our z-score was for the boxers. And once we did, I would look for these two answers. That would be part of what I was looking for. Plus, I would look for that you were telling me the answer to the question, which asked which dog was more underweight and explain why. So the boxer is more underweight, and this is because the boxer is more standard deviations below the mean than the Dalmatian was. Okay? All right, because it was 3.24 standard deviations below the mean, where this one was just 1.52. All right, next, we were then asked if we had a temperature of 97 degrees, which 97 is the X. And so the question asked what percent. So this idea, again, percent, probability, proportion of observations, you're going to have to norm CDF to find that area. So they gave us the mean, standard deviation, and X. And so then you had to get the z-score down here and find this area below. So, that's a little hint is we would need to do our probability notation of having a z-score less than negative 2.43, and it was that value there, very small. The reason, again, that we needed to go less than is because we were talking about those with hypothermia who have low body temperatures, not low boy temperatures, but low body. Find the temperature for that lowest 15%. So that is this lowest 15% down here. So we do have a low percent, which if they give us the low percent, then we are ready to go. We are ready to get that value of that z-score. So I want to see that there, and then I want to see this formula written out where you are then ready to solve for the unknown value of x, which was 97.97 degrees. So if you had 97.97 degrees, you're in that lowest 15%, which is interesting. Here we go. Next. So these were actual AP questions. So they were a bit wordy, but you've got to learn how to read a prompt and not just comb it for the numbers. You have to be able to read and talk about what it's asked, see what it's asking for. So here we had a mean distance of 288 and the standard deviation of 2.8, and we wanted to know what proportion of these golf balls travel too far. Well, you'd had to read up here that this manufacturer wants it to go as close to 291.2 without exceeding that 291.2. So that 291.2 is that cutoff value that you do not want to go past. And so then that's why it was the X value. And they asked what proportion of golf balls were in this section past 291.2. So if we were doing that probability notation, we would be talking about the z-scores that are greater than 1.14, and that was 12.71% of balls. So that's quite a bit. If you're a manufacturer, then you might have a bad reputation because that's quite a bit of your golf balls that you're producing that are exceeding the limit, that the specifications that they are supposed to meet. So part C says, well, they want to fix this. They want to calibrate their machines so that 99% of the golf balls do not go past that limit. So 291.2 again is the X value, and we want 99% of the golf balls below that amount. So that's how we get our z-score for that inverse norm of 0.99. We then can fill in this equation, and the question asked what should the mean be? And so we go through the math. So there's where they should calibrate the machine to. So to set the mean so that 99% of the golf balls will not exceed that limit. All right, next we had this 70th percentile of the stopping distances. 70th percentile. Percentile means you had 70% at or below. If you were in the 70th percentile for height, you have 70% below you in height. So that's how we knew it was inverse norm of 0.7 to get that z-score. Then we set up our formula here, and then we solve for the x value, which means 128.38 would be the 70th percentile. Here, we wanted to know the probability, so we're going to have this probability notation that we had a carton of eggs a full carton that weighed more than 850 grams. So that was greater than, see, look, here was the data I was given. So I did find my z-score, and I wanted to know the probability that I get a z-score greater than 1.27. And that was 10.2% of cartons will weigh greater than that 850 grams. Here we again have another one. If more than 140 students are absent, then they will not qualify for the funding. So here we then had this data given to us, so we get our z-score. And so what proportion of the years or the school days do they run the risk of not getting funding? So the probability that you get a z-score greater than 1.9 are the days. And so then that is just the 2.89%. All right, and then again, similar thing. What's the probability? So this is our probability notation of getting a z-score. We wanted greater than, and when you do this z-score formula, it was just a z-score of 0.8, so not very unusual. So that's why we had 21%, 21.19% chance that a randomly selected melon from distributor J will have a diameter greater than 137 millimeters. And that was the end of our warm-up to make sure that you are prepared for your normal model quiz.